Diane actually has a really nice little kind of moment on the other one. You'll have to listen to find out what it was. Okay, so if I'm saying I'm thinking of the sine of 70, and we'll think about that a little bit more carefully here in a second. But I think of the sine of 70. The sine of 70 should be equal to the sine of what angle? The sine of 70 should be equal to the sine of what angle? Before we do anything, what do we need to do? Think back to the pro tip. So let's all take a second and sketch our unit circle here. Sketch our unit circle, and then go ahead and sketch 70 degrees on that unit circle. And think to yourselves, actually, for 15, 20 seconds, the sine of 70 degrees, well, that should theoretically be equal to the sine of what angle?
Since the sine of 70 is its y, no, is its x, it's y coordinate.
So if I've got 70 degrees,
Since the sine is its x coordinate,
is it its x or its y?
Y.
Right. So I'm thinking opposite here over 1. Yeah, so that's going to be y. So this is the sine of 70 degrees. Okay.
Any other angle that shares that y coordinate.
Love it. So Zachary just said, I'm even going to write this down. There's so many modes here. Any angle that shares its y coordinate with 70 degrees. Finish that sentence, Zachary.
Any angle that shares the y coordinate.
Yeah.
Has the same sign.
Yeah, word. Props right there. Except I can't spell your name. All right, there we go. Yeah. So, where are we going to find that other angle, Zachary?
Well, we could mirror the angle on the other side and use 110 degrees.
Interesting. So if I were to, Zachary's words, he kind of mirrors it. And Zachary's suggesting that this angle is 110 degrees.
It's 70 degrees from the x-axis on the other side.
Love it. 70 degrees from the x-axis on the other side. So if I were to actually sketch in a right triangle here, I know the hypotenuse is 1, and this angle is 70, what must be true about these two triangles? This is interesting to me. If I've got an equal side, an equal angle, and an equal angle, what do I know about those two triangles? They're congruent. Yeah, nice. So if the triangles are congruent, what do we know about all their side lengths? They're equal, right? So thus, this y value right here is going to be equal to this y value. Thus, is going to equal the sine of 70. And I like it. Zachary's saying, well, if this angle is 70 from the x-axis, this angle is 70 from the x-axis, then this angle here would be 110 degrees. So thus, we can say that the sine of 70 is equal to the sine of 110 degrees, right? Because they have the same y coordinate. Question, yeah, Martin.
Also, would the sine of 450 degrees?
Yes, capital. Indeed, the sine of 450 would also be equal. 450? Wouldn't it be 450? No, 360
470
is 430?
Yeah.
Yeah, genau. Yeah. 430 degrees. Yeah, you're right. And to save ourselves the headache of really the infinite number of angles, right, that would have the same sign, could be negative, negative 270, and then another 20, right? So negative 290 could also work. Indeed. To save ourselves some of the headache, sometimes it's nice to just think of angles. So I'm going to say angles where theta is between and including 0 and 360. Sometimes that's helpful. Right? Because otherwise you can say like, all right, like 430 or 790 or 1150. I can't. Yeah, too much addition there. I lost it. But let's try and keep the angle, perhaps between 0 and 360. So what we are going to work on, what you can work on right now, is page 10 of your trigonometry packet, which is going to be asking very similar questions to this one.